Hey, Mr. Sue.
What's up, Mr. Sue?
Unit
7.
video coming up.
Chase takes 9 minutes to clean the living room.
What's that?
John and Chase working together takes 6 minutes. How long would John take to clean the living room by himself? Okay, so we're going to find the amount of time it takes John to clean the living room by himself. So this equation is what we're going to use to find that. So X represents the amount of time it takes Chase, Y is the amount of time it takes John, and Z is the amount of time it takes together. So we already know the amount of time it takes together, it's 6. And then 9 is the amount of time it takes Chase, 9 minutes. So we first need to find LCD. So now this is all factored out, the denominator. It's 9, Y, and 6. So when you multiply that together, you get 54Y. Once you get the LCD, least common denominator, you multiply the LCD to each of the fractions. So you do that. So you can see you get these new fractions. You cancel out the Y's. And you get 6Y plus 54 equals 9Y. Once you subtract 6Y from both sides, you get 54 equals 3Y. Then, final step, you multiply both sides by 3. Quick correction. You actually don't multiply. I said multiply, you divide both sides by 3 to get 18 minutes.
Finally.
So John finds a rock. He needs to move the rock from one room to another. John is going to build a lever to see how much force is needed to move the rock if the distance is increased by 15 feet. So we know that the rock weighs 200 pounds, and to lift the rock, we need 50 pounds of force and a lever with a distance of 20 feet. We want to know how much force is needed if we increase the lever to 15 feet. So our equation for force is going to be F equals to K over D. So as we write that out, it's going to be 50 equals to K over 20. And what we do is we put both sides in parentheses and we multiply that by 20. And that comes out to 1,000. So to find the force, we're going to put 1,000 over 15 because that's how much feet is increased. And once we divide that, we get force equals to 66.7 pounds per foot.
Alright, so for the last step, we're going to do, so with a force of 200 pounds, how far does a lever have to be from you to lift the rock? So what we're going to do is F equals K over D. So we have 200 over 1 equals 1,000 over D. So then what we're going to do is cross multiply right here. And then after we get 200D from here. And then equals 1,000 right here. And then after that we do a divided by 200s from both sides. And then we cross this out. So then it becomes D equals 5 feet because 1,000 divided by 200 equals 5.
Okay, so for number 4, our main goal is to solve for X. So first we got to find the LCD, which is the least common denominator. So in these fractions, first you got to put 1 as a denominator under 2, under negative 2. And then you factor out these two equations. So you get 4 on the outside, and then you get the 2 on the outside. And then you just simplify, so you get this 2 cancels out, and the 2 goes on top. Then you get the LCD, because you factored completely, which is X plus 4. Once you got the LCD, you multiply it to each of the fractions. And as you can see, this cancels out, and then this just becomes an equation where you're going to distribute. So then once we line all of them up, we just distribute. And then you add the like terms. And it comes out as 6 equals 2x plus 10. Subtract 10 from both sides. And then, final step, once you divide by 2, you get x equals negative 2.
Okay, so here we have our lever, and on one side we have a helmet that's about 1 pound, and we have a hat on the other side that's about 5 ounces. And at this point, the lever is balanced, and what we want to do is we want to have the lighter hat lift the heavier object, which in this case is the helmet. So we want to demonstrate how by lifting the focal point, which is the middle of the balancing point, can change by moving either left or right. So if we move it just slightly to the right, increasing the distance from the hat to the focal point, we can actually lift the helmet slightly. And this is used by moving the focal point and the distance from the hat to the helmet. As you can see there, the hat completely lifts the helmet.